So if we have the RAM, then we'll be having also the ROM. Okay, so there are different types of ROM. So let me use again our curriculum so that you can see different types of memory module. Okay, so in early days, so they have this what they call deep switch. Okay, so when we said memory module, this is the RAM, okay, or the physical RAM or physical memory that we are referring, okay, that we usually insert towards to our motherboard. Okay, so early days we do not have the single inline memory module or the dual inline memory module. So they do have the DIPs. Okay, so the dual inline package, or somewhat calls in terms of integrated chips. That is why during 80s our motherboards is quite huge or quite big. Okay, because they need to embed, okay, install of all of this deep switch, okay, towards the motherboard. And then, okay, as the technology advanced, okay, its particular module, so all of those deep switches being integrated to a single module or memory module. They call it SIM. So single inline memory module. So one line, okay, of the module has those deep switch or deep ICs. Okay, and then mostly they are having 30 to 72 pins of the pin configuration. Then we do have the DIMM or dual inline memory module. Okay, mostly their types are the SDRAM, the DDR, okay, um, SDRAM or DDR2, okay, SDRAM DDR3, SDRAM DDR4, okay, that comes with the different pins. So we do have 184 pins, 240 pins for DDR2, and DDR3 is ranging from 288 pin, okay, of DDR4 DIMM. Nowadays, early 2019, they already launched the what they call the DDR5. So, but it's not yet very familiar with the market right now. But sooner, okay, you will be hearing the what they call DDR5. Okay, so most of this memory module, okay, differs from the number one, the capacity, number two, the speed of processing, okay, speed of communicating towards to our CPU, okay, and to our different buses. Okay, so the last part here are the SODIMM, okay, small outline dual inline memory module. Mostly they are 72 pin, 100 pins, okay, 144 pins, 200 pins, and 204 pins, as well as 260 pins. They are all being used in our laptops or um, yeah, laptops. Okay, so those are the different modules, RAM modules. We also have the cache memory. Cache memory, when talk about L1 cache, this one is internal cache and it's been integrated inside the CPU chips or the central processing unit chips. Okay, so a CPU can have a various model each with the different amount of L1 cache. L2 is a cache, okay, external and was originally mounted into your motherboard. Okay, so L2 cache is now integrated into your CPU. So there is CPU that integrates L1 and L2, okay, nowadays. And L3 are used on a high-end workstation or server CPUs. Okay, so most those having L3 cache memory are those with the server type. Okay, and we also have the non-parity. Non-parity memory does not check for errors in your memory, and non-parity RAMs is the most common RAM use in terms of home or business workstation. So our ordinary desktop uses non-parity. Okay, for parity memory contains 8 bits of data, okay, and 1 bit for error checking. So it has a parity check, okay, wherein it calls parity bit. And we also have the error correction code memory which can detect multiple bit errors in memory and correct single bit errors in terms of the memory. So mostly they will use in terms of servers, okay, and some data analytic. Okay, so that's why we have the ECC memory module, which might be required. Okay, so what are those cache memory and compare with the um, dynamic random access memory? Okay, so dynamic random access memory are being popular until mid 1990s. So they are used as what they call the main memory. So they've been used in terms of the what they call the dynamic random access memory. Okay, so two types of RAM are either dynamic or static. Okay, so those cache memory are example of our static RAM. Okay, so when you talk about static RAM, it requires constant power to function. So one reason why we do have batteries in our motherboard, so because this type of memory needs a constant power to function, often used for cache memories. So those L1, L2, and L3 are example, okay, of a static RAM. So it uses lower power consumption and it's much faster than the dynamic RAM. So the dynamic RAM is the reverse. So the RAM gradually discharges energy so that it must be constantly refreshed. Okay? So that's why when you power up your computer, the dynamic RAM will totally erase all of the data, okay, stored on those part. So the first type of dynamic RAM, okay, is the synchronous, okay, or synchronous dynamic random access memory, or they call it SDRAM. So this one operates in a synchronizations with the memory bus. Okay, so remember I drew a while ago, we have the data, the control, and the address bus. So those are bus lines that being communicated by the random access memory. So once we have the synchronization, so they will have the same speed of in and out of the particular data. So also the DRAM able to process overlapping functionality in parallel with your buses, which can process read before it can be written, okay, will be completed. And the dynamic RAM is having higher transfer rate, okay, transfer rate between your CPU, okay, CPU process going to storing the particular data. So that's what we call the synchronous dynamic RAM. We do have older versions of our dynamic RAM. We have the fast page mode, okay, before, okay, before it comes to the SDRAM. Okay, so several types of SDRAM are the DDR. Okay, so it's just, okay, in terms of multiplying in double the data rate. Okay, that's why they created DDR, or double data rate. So the DDR, as I told you a while ago, it happens to have 184 pins on a single notch. Okay, and it uses lower standard voltage, which is 2.5 volts. Family of the double data rate are DDR2, okay, older versions of DDR2, older versions of DDR3, and older versions of DDR4. Okay, so when you talk about DDR2, okay, so that DDR2 is having higher clock speed from ranging from 553 megahertz, okay, up to the rate of 200 megahertz to 553 megahertz. So it improves performance by decreasing the noise crosstalk. Okay, so somewhat you will not hear a lot of noise in terms of DDR2. Okay, and it uses lower voltage, which is 1.8 compared to 2.5 on our DDR. Okay, DDR3 is again we multiply, okay, the double data rate, okay, maybe 3 times. That's why they call it DDR3. Okay, so it expands the bandwidth by doubling the clock rate of DDR2. So they double it again, and still power consumption is 1.5. It generates less heat. Okay, the first two a while ago, it generates high heat part in terms of their chips. And the DDR3 usually runs with 240 pins, so you will see 240 pins. Okay, and then the DDR4 is there. So DDR4, much lower voltage that we have 1.2 volts. Okay, so it means lesser than DDR3. So when we have some lower voltage, so it means that less heat, okay, and it might run on a higher clock speed, so around 1600 megahertz, okay, with 288 pins. So then we do have the GDR, okay, SDRAM. So G stands for graphics. So the GDR is being used majority in terms of the graphics cards. So nowadays, when you buy graphics card, you need to check how many RAM that those graphics card has. So that RAM in the graphics card is known as the graphics DDR. Okay, so it also used in terms of the dedicated GPU or graphics processor unit. Okay, so those are the different types of memory module. Okay, so we discussed it already a while ago. So let's go now with the adapter cards. So adapter cards are the additional components that increases functionality towards to our computer by adding controllers. Okay, so for example, if I need network connectivity, then I'll be using a NIC card or network interface card. If I need more sound quality, then I'll be adding sound card adapters or sound adapters. If I need additional connections for my internal drives, okay, so I can add eSATA. If I want higher graphics, okay, so I can have video card. Okay, so other types of cards which are not here in the pictures are the wireless network cards, okay, capture cards. So we use it for capturing from live streaming, or if you want to use your web camera, okay, to record towards your computer, so you will be needing a capture card. So if you want to watch television channels from your computers, then you will be needing TV tuner. But nowadays, TV tuner is no longer being used because we do have the Netflix, we do have some internet movies, okay, or majority of the media broadcasting are now shifting to the IP network. So very less nowadays are using the TV tuner. Universal serial bus, okay, if you want additional USB controllers, and the eSATA as I told you a while ago. Okay, so adapter cards can be installed in the different types of, okay, expansion slots. So we do have different common expansion slot. So first we do have the legacy expansion slot called the peripheral component interconnect, or the PCI. Okay, then from PCI it's been developed to um, mini PCI. Nowadays we are having the PCI extended. Okay, most of high-end computer nowadays are using PCI Express. Okay, and the older part of expansion slot, same with the PCI. Nowadays we still have PCI into our motherboard, but before they have this what they call the AGP, or accelerated graphics port. Okay, so how you going to compare? PCI can have 32 to 64 bit expansion slots. Okay, so that's the size of the transfers. Okay, mini PCI is being used majority on our laptop. Okay, so mobile devices. Okay, so we have the mini PCI, or when you go with the another chapter, which is the mobile devices and laptops, then you will be able to see there where are those mini PCI. Okay, so PCI-X, or we call it PCI extended, okay, is the updated versions of the PCI, okay, on the desktop computer, that also have 32-bit bus and higher bandwidth of PCI. PCI can operate up to 4 times faster than PCI. So that's why they created the PCI-X. Much faster is the PCI Express. So PCI Express uses a serial bus that has higher throughput and many other improves in terms of the older expansion slots, which is the PCI-X. So these are the PCIe with times 1, times 4 on terms of the speed, times 8, times 16, okay, in terms of the slots that varies the length of shortest to longest, okay, respectively in terms of the type of slots. Okay, riser cards are being used in majority of some compact, okay, compact style of desktop. So instead of the motherboard lying, or the expansion slot lying on the particular board, okay, so I can use a riser card. Okay, so if this is the motherboard, so I will use a riser card. Then you will put the expansion cards, okay, on the slot of the riser card. So that's what we call the riser card. Okay, and the older AJP, accelerated graphics ports, is being used for video adapter cards, okay, on the older PC. Okay, so types of storage. So we do have the data drives, okay, provides non-volatile storage. Okay, some drives have fixed media, and others have drives that have removable media. So what are those with removable media? We do have the optical, okay, tape drive, okay, the older hard disk drive, but currently we're still using this hard disk drive, okay, that has motor, okay, and magnetic disk inside. And also we have the SSD, which is mostly the current, okay, standard nowadays. Okay, but we do still have the hard disk drive, okay, but we do have now the solid state. Okay, So the comparison is this storage devices, or as I called, secondary devices or secondary storage, okay, are having some motors, okay, being run by some motors, okay, while our solid state drive, okay, is somewhat a RAM chips, or it's being stored and use a particular chipsets. So that's what they call solid state drives. In comparison, solid state drives are much faster comparing to the storage devices known as with hard disk drives. Okay, so we'll have those explanation now. Let me show you the hierarchy of the devices, why they called primary and secondary. So this one at the topmost, okay, part is the CPU. Okay, below the CPU are the two primary memory. So because these two particular types of memory, so we have the RAM, okay, and the ROM, okay, access directly towards to our CPU. On the third line are the secondary drives. So different types of secondary drives must be there. So we have the hard disk drives, okay, the optical drives, okay, the SSD drives, and the tape drives, okay, so which are here on the third layer. So at the lower layer are the input output devices, okay, such as your keyboard, your mouse, your other peripherals, your monitor, okay. So one reason why, if you're going to observe, before a keyboard, okay, reach the processing, so it needs to be known first to your, or needs to be saved, the informations in our hard disk drives through our operating system. Then the hard disk drive will throw that particular informations to the RAM, okay. ROM will check whether that keyboard is registered into our interrupt request, okay. From the interrupt request, it will be passed through to the CPU, and CPU will evaluate the instruction, or will evaluate the processing. Then it will go down again, go back to your input output devices, okay. So that is why very important that you must have a faster RAM, okay, and large capacity of secondary drives, okay. So that's why it calls primary here, and this type of storage devices are known as the secondary drive. So those are the all, okay, explanation in terms of the hierarchy of our devices, okay. So if we have different storage devices, then they must have different interface on how they going to be connected towards to our motherboard. So storage devices interface are the inside a computer connects towards to your motherboard using serial AT, okay, or advanced technology attachment, okay. So that's what we call ATA. So, or called as SATA. So the legacy, the older versions of SATA is the PATA, or what we call the parallel ATA. Okay? Parallel ATA is being enhanced with EIDE or the IDE. So we call it IDE as integrated device electronics, and the EIDE is the enhanced integrated device electronics. So the physical standard defines the way the data transfer, or the transfer rates, and the physical characteristic of the particular cable that you're going to connect going to your storage devices. So there are three main versions of SATA. So we call it SATA 1, SATA 2, SATA 3. Okay? So they are deeper in terms of the speed, okay, of reading, writing, okay, and communicating with our primary memory. Okay? So there are three main aspect in terms of the speed. So SATA 1 allows for maximum data rate of 1.5 gigabits per second. SATA 2 is having 3 gigabits per second, and SATA 3 is having 6 gigabits per second. So the higher the speed, okay, in terms of the processing, the much faster performance that you will be having in terms of um, the communication towards to your primary, going to your central processing unit. Okay, so we do have the legacy, one of the oldest also. We call it SCSI drive, okay, or serially attached SCSI or SAS. Okay, so small computer system interface, we call it SCSI, is another interface between motherboards and the data storage devices or your secondary storage. So these are some older standards that we have. So they being released, okay, the SCSI drive is being released together with the EIDE. Okay, so nowadays we're no longer having those part, okay, or those type SCSI. Okay, so magnetic media drives, so it means they are the storage represents in terms of binary values as magnetized or non-magnetized physical area of magnetic media. So common type of magnetic media storage devices are hard disk drives, okay, traditional magnetic disk, we call it magnetic disk, with a storage capacity nowadays of gigabytes or terabytes. Okay, so during the old versions, we're having the tape drive used to back up, okay, datas from servers. So tape drives uses also magnetic read-write heads, okay, and common tape storage capability are having some gigabytes and terabytes capacity also, okay, which are being used for backup system. Okay, so the latest one, okay, which are very common in the market right now, are the semiconductor storage or the solid state drives. This one stores as electrical charges in the semiconductor flash memory, which makes SSD much faster than the magnetic disk. So in the magnetic disk, we need motor. Here, there will be no motor movement inside their storage devices. Okay, so this has low noise or no noise at all and are energy efficient. Okay, so it uses less power and produces less heat in terms of the hard disk drive. So compare it with the hard disk drive. So SSD comes on three different types. So we do have the SSD 2.5 drive. So this is somewhat your mini hard disk drive. Okay, mostly found in majority of our laptop devices. But nowadays you can also put SSD 2.5 drive inside our desktop computer. Okay, we also have the SSD M2 drive, okay, somewhat the same with a memory, okay, a RAM memory. Okay, it looks like a RAM memory, but this is not a RAM memory, but this is an SSD or solid state drive called M2 drive, okay, or the M-SATA or M2 module. Okay, so package used for special socket called M2. Okay, so it has a expansion slot also that you need to slot. So majority of high-end laptops is having M2 SSD or M2 SATA. We also have SSD adapter, okay, or expansion cards, which you will plug directly into your motherboard. The problem here is if you are having only one PCI Express, so majority of the SSD adapter cards are PCI Express, and you use already your PCI Express into your video card, then you will not be able to use or add another SSD adapter cards. Nonetheless, your motherboard is quite high-end and you do have two different PCI Express. So we do have motherboard that has two PCI Express. Then you can add one more, okay, expansion cards for SSD. Okay? So semiconductor storage, it has non-volatile memory express, which specifications was developed specifically to allow computers to take greater advantage in terms of the features of the solid-state drive, okay, by providing standard interface between your SSD and your PCI Express bus and to your operating system. So the non-volatile memory express, okay, allows compliant in terms of SSD drive, okay, to attach with your PCI Express without requiring special drivers. Okay, so somewhat it's a plug and play, okay, in terms of the operating system. So solid state hybrid drives, okay, so when you said hybrid, so it has a combination of magnetic hard disk drive and SSD. So they said they are much faster than the hard disk but less expensive than the SSD. So that's why they created a hybrid type of storage. Okay, they combine both the technology of magnetic hard disk drive and the solid state drive. And we do have, in terms of the optical storage, nowadays very less that you will see in terms of your desktop and when you buy laptop, okay, very less that they are packaging optical storage devices, okay. So but the legacy is coming from the compact disc, then the DVD, and then nowadays we do have the Blu-ray disc. So Blu-ray disc being used by some of the gaming console called PS4, okay. So they integrates Blu-ray disc there. Okay, nowadays there are very less, okay, people who are now using these types of optical drive. Okay, so how they differ from one another? So in terms of the capacity is one big difference. Okay, from CD, compact disc up to DVD and Blu-ray. Okay, Blu-ray has higher capacity into a single layer or a dual layer. Dual layers means there is a data from the top of the disk and there's a data at the bottom of the disk. Okay, so there are different types in terms of the optical media. It varies from read only or recordable. Okay, it means recordable media can be recorded one time. Okay, rewritable media can be recorded and erased again. So that's what we call the rewritable. Okay, so there is a third one, we call it recordable. So recordable media can be recorded one time, okay. And rewritable part, okay, is the erase and write. Okay, so video ports. So it is also very important to know the different video ports and cables, okay, on how we're going to interface onto the different devices, different input and output devices. Okay, so it varies from the video card connector. So let's have familiarization of video card connector. So this is what we call the DBI, okay, connector. Then we do have the display port, okay, and the HDMI, okay, which are three most common video card adapter ports that nowadays we're using. Okay, so DVI means digital visual interface. Okay, then we do have the display port. Okay, display port is an interface technology that is designed to connect high-end graphics capable PC. Okay, mostly of those workstation is having display port. Okay, nowadays we're using the HDMI. Okay, or high definition multimedia interface, okay, which also you can see on majority of your smart TV, okay, so because it uses high definition, okay. We also have the Thunderbolt. There are different versions of Thunderbolt. So this white one here is a Thunderbolt versions 1 and 2. Okay, so it has a high-speed connections of peripheral devices. When you connect a device, external device over Thunderbolt, so there's a high-speed connection. Okay, so what are those? Such as we have RAID arrays. Okay, we have hard disk drives and some network interface can be attached towards to a Thunderbolt 1 and 2. Okay, how about Thunderbolt 3? So almost it's an upgraded versions of 1 and 2. Okay, so but it uses somewhat the same with the type USB-C. Okay, so that is the Thunderbolt, okay, 3. And the legacy video connector or video cable, we call it BGA. Okay, and much older is what we call the Radio Corporation of America, or we call it RCA. Okay, so these are being used on some older audio. So the white and the red here is for audio. Okay, and this one here is a standard for video. So video and audio combines towards to this Radio Corporation America, or RCA, which is nowadays we still using those RCA. Okay, other ports and cables, so very familiar, which is for the keyboard and mouse. Okay, we do have game port for your audio and game port. So network card, so which will be very familiar when you talk about, or when you study later in terms of networking. Okay, so this is a SATA connector. The smaller one here is the SATA for the storage device, and the other one here is a SATA power supply connector, which will be coming from the power supply that you have. Okay, so this is for the EIDE cable. Okay, this one, it's having 40 pins of connections, which you're going to, the black one can be, or the black or the blue one can be plugged into the board. Okay, and then the red one will be plugged to your hard disk drive or optical drive. Okay, so that is the use of the IDE cable. Then the most standard types of ports and cables is what we call the USB drive. Okay, universal serial bus. Okay, so if you have connectors, you might be having different converters. So for example, in my video card, I only have DBI, but in my monitor, I do not have DBI, but you have BGA, then you can have a DBI to BGA adapter. Also, I do not have enough slot for another card, okay, or another internet card, or network interface card, sorry. Then I can have a USB, plug it to my desktop PC, and it will detect that this is a Ethernet. Okay, so he will convert already from Ethernet going to USB, USB going to Ethernet. And also, nowadays, very minimal that we will be using a PS/2 type of keyboard and mouse. But if you don't have those connector, okay, into your board, then you can buy a USB to PS2 adapter. Okay, so that you're not going to replace the entire keyboard and the mouse. Okay, then we also have the DBI. This one is the DBI. Okay, and it can be converted into HDMI cable. Okay, also we have the Molex to SATA adapter and the HDMI to VGA converter.